In this video, we are going to talk about the properties of exponents. So we're going to start with the 7 most common properties of exponents that exist. The first property says that if you have a to the m times a to the n, then assuming that these bases are the same, which they are, you can then add the exponents and the result is a to the m plus n. Property number 2 says that if you have a to the m to the n, so sometimes this is referred to as power of a power, you can then multiply the exponents, so a to the m times n. The third property says that if you have a to the m over a to the n, this is very similar to property number 1, notice, except that the operation here is division instead of multiplication. So assuming that the bases are the same, then you can have a to the m minus n. Fourth property, a to the 0, anything to the 0, any exponent or value for that matter to the 0 is always equal to 1. Property number 5, the one that probably is the most challenging for students to wrap their minds around, is a to the negative 1. This is really 1 over a to the first. So two things happen here. Number 1 is that there's a reciprocal to that one particular term. So the a, the base a, goes to the denominator. That's number 1. Number 2 is when that happens that the exponent, notice, goes from negative to positive. Property number 6, when you have a times b to the n power, you can multiply, just like we did with number 2, we can multiply the exponents, but notice here the exponents with a and b are both 1, so this is a to the n times b to the n. So multiplying the exponents, only the exponents. Property number 7, last one, very similar to property number 6, is if you have a over b to the nth power, this results in, again, you're going to be multiplying the exponents. Exponent of a is 1, b is 1, so it'll be a to the n over b to the n. Let's now use those 7 properties to simplify these two particular problems. So the first thing with this problem I noticed is that there's an exponent on the outside. I also noticed that there's a's, b's, and z's as bases with your numerator and denominator. So there's actually a couple different ways to do this particular problem. I'm going to choose one way. So I'm going to start by simplifying the base a's, b's, and z's. So since it's division, I'm going to be subtracting the exponents. So this will be a to the negative 1, b to the second. Remember, this is a b to the first, so 3 minus 1. And finally, z to the negative 5th. Don't forget there's still a 2, fraction, and the 3 remains in your denominator, parentheses, and all to the 3rd power. All right. From here, again, we have some choices. We can choose to simplify by distributing or multiplying that exponent of 3 to all other exponents. Or you can take care of the negative exponent. We do not want a negative exponent as part of our answer. So I'm going to choose to work within the 3, the exponent of 3. So this will become 2 to the 3rd times a to the negative 3rd times b to the 6th times z to the negative 15th all over 3 to the 3rd. Okay, so we have a couple different things we need to do. Number 1, we need to evaluate 2 to the 3rd and 3 to the 3rd, which is 8 and 27. Reduce if possible. Next thing we need to do is take care of the negative exponents. So remember what I said with the negative exponents, and that is that the base is the reciprocal of the base. So this is a in the numerator, so a must be in your denominator, and by doing that you make it a positive exponent. B stays where it's at because b is a positive exponent, so it remains in the numerator. Z is a negative exponent, so it must also go to the denominator. So z to the 15th, and you make that a positive 15, and that is your final answer. For number 2, we are going to go ahead and multiply these, and one thing I'd like to do, since multiplication is all commutative, now remember this is all multiplication throughout this entire problem, so since it's a multiplication and multiplication is commutative, it means I get to rearrange this however I want. So I'm going to choose to put the 2 times the 4 first, so I'm going to make basically regroup these so that they're all the same bases, or in this case the constants. So then you have x to the 4th times x to the negative 5th, and you have y to the 7th times y to the negative 2nd. Now, you don't have to do this. Some people can do this particular problem without rearranging. I just felt like it helps some people. 2 times 4 is 8. X to the 4th times x to the 5th is x to the negative 1st. And y to the 7th times y to the negative 2nd is going to be y to the 5th. Okay, so now we have 8, which is fine, and we have y, which is fine, but notice how the x has a negative exponent, and that is not okay. So we want to move that to the denominator and make it x to the 1st, and you don't even need to really write the 1st, but it is just simply 8 times y to the 5th over x.
Cowabunga, dude!